Hey, Algebra 2 friends, here we are in chapter 11, and we're going to be looking at arithmetic sequences. So let's look at some vocabulary. First, we have the word sequence. What is a sequence? Well, a sequence is a list of numbers in a particular order. So this is a common sequence that you all are familiar with, right? So we've got the sequence of even numbers 2, 4, 6, 8, so forth and so on. Each of these numbers in the sequence would be considered a term. So a term is just one of the values of the sequence. When we talk about sequences, we actually number them. So we might call them the first term, the second term, the third term, and we will use a sub characteristic to refer to them. So 4 is the second term of the sequence. An arithmetic sequence is a special kind of sequence where you generate each subsequent number by adding a number to the previous number. So for instance, if I had the sequence 1, -3, -7, -11, you could recognize that I am adding from each number to the next number a -4. So 1 plus -4 is -3, -3 plus -4 is -7. You guys see where we're going with this. And then so forth and so on. So an arithmetic sequence has to have that quality where you're constantly adding the same number, or you could look at it as subtracting, but I'm going to just say adding because I can add a negative. The common difference refers to the number that we're adding. In this problem, the common difference would be -4. So it's the number that you are adding to get each next number in the arithmetic sequence. And finally, the term arithmetic means. If we go back to our 2, 4, 6, 8, 10, 12, 14, 16, blah, blah, blah sequence, when we have a few spaces between, or when I talk about the spaces between two terms of a sequence, those are called the arithmetic means. So for instance, I could say find the 4 arithmetic means between 6 and 16. So this statement would be referring specifically to the 4 numbers that would build up to 16 from 6 in this arithmetic relationship. Okay? So anytime you have non-successive numbers that are in an arithmetic mean, but they are not side by side, then between them you can have numbers that are in an arithmetic sequence, but are not side by side. Between them you can have arithmetic means, 2, 3, 4, 1. Okay. So here in our first example, we are required to find the next 4 terms of this sequence. Well, we're dealing with arithmetic sequences. Not all sequences are arithmetic, but we are dealing with arithmetic sequences. So I hope to find a common difference between these numbers. It looks like I'm going from 55 to 49, which is adding a -6. 49 to 43, adding a -6. So now that I've got the pattern, I can continue on. I'm just going to add -6 each time. And so the terms I get will be 37, 31, 25, and 19. And recognize between each of these is a drop of 6, or I'm adding -6 to each previous term in my arithmetic sequence. So as we discussed before, each of our sequences are made up of several terms. Sometimes they are called A or T or something like that. So A sub 1, A sub 2, A sub 3, so forth and so on. All the way out to A sub n, if there's a number that we're going to stop at, or a number that we want to know about, the nth term. So A sub 1 will be the first term. Now, here's a formula that you've probably seen before. I feel like I've done this before in Algebra 1 with you guys a long, long time ago. But we talked about arithmetic sequences there, and we have this wonderful equation that's not really hard to derive, but it makes a good bit of sense. If you want to figure out what A sub n is, whatever that number is, A sub 50, A sub 1,000, there's some information you need to know. The first thing you need to know is you need to know the first term of the sequence. Then you need to know D, which is referred to as the common difference. Finally, knowing the number that you're looking for, the nth term, you take that number, you subtract it by 1, you multiply it by D, you add it to the original term, and then you can get A sub n. In the next example, we'll be using this formula. So here in example 2, we're going to find a particular term. We're going to refer to the information at the left, assuming that the arithmetic sequence continues. How much would it cost to rent the crane for 12 months? So you notice we have information about the first 4 months. In a sense, we could look at that as the first 4 terms of a sequence.